Hello everyone. Today we're going to learn about Chapter 5, Work, Energy and Power. First of all, we have 5.1 Work. At the end of this lesson, you have to know how to define the work done by a constant force. Work done by a constant force can be defined as two different meanings. The first one is the product of the component of the force parallel to the displacement times the displacement of a body. Or the second one, work done can be defined as a scalar product between force and displacement of a body, which is work done is equal to force dot displacement. So F is the magnitude of force, S is the displacement of a body, and the theta is the angle between force and displacement. Well, work is a scalar quantity, which means it only have magnitude but no direction. And the SI unit for work is joule. Well, that's it for 5.1. So let's move on to 5.2, energy and conservation of energy. Energy is the ability to do work. That's why the SI unit for energy is the same like work, which is joule. Energy is also a scalar quantity like work. In this chapter, we will learn about two different mechanical energy. First is kinetic energy, and second one is the potential energy. And the potential energy can be categorized by two different types, which is gravitational potential energy and elastic potential energy. Well, the principle of conservation of energy states that in an isolated closed system, the total energy of the system is constant. That means the initial energy is equal to the final total energy. The conservation of mechanical energy is defined as total energy is equal to kinetic energy plus potential energy is equal to constant, or kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Well, what is the kinetic energy K? Kinetic energy is the energy of a body due to its motion. Well, K is equal to half mv square, where m is the mass of a body and v is equal to speed of a body. Well, what is work kinetic energy theorem? It stated that work done by the net force on a body equals the change in the body's kinetic energy. Or mathematically, work done is equal to delta K, or K final minus K initial. Well, potential energy is energy stored in a body or system because of its position, shape, and state. Well, let's cover the gravitational potential energy first. It was the energy stored in a body or system because of its position. Gravitational potential energy U is equal to mgh, where m is the mass of the body, g is the acceleration due to gravity, h is the height of a body from the initial position. While elastic potential energy is energy stored in elastic materials as a result of their compression or stretching. U is equal to half kx squared or half fx, where F is the restoring force of the spring, K is the spring constant, x the amount of stretch or compression, and U is the elastic potential energy. So work gravitational potential energy theorem basically is the same thing like work kinetic energy theorem, but we are using the potential energy instead. Same with this, the work elastic potential energy theorem is also the same thing, but we are replacing the potential energy and kinetic energy to the elastic potential energy. In this energy, we are applying the Hooke's law that you have learned in school before. Hooke's law states that F is equal to negative kx, where k is the spring constant and x is the stretching or compression amount. Well, this is also the same thing. Work energy theorem is the work done by the frictional force on a body equals the change in the body's total energy. Instead of using the kinetic energy and the potential energy, we are using the total energy this time. Next is the 5.3 power. So what is power? Power is the rate at which work is done. It is also a scalar quantity. The SI unit is watt, not joule like work and energy. Well, the average power is work over time or energy over time. Meanwhile, the instantaneous power states that the power is equal to Fv cos theta or F dot V, where F is the magnitude of force, V is the magnitude of velocity, and the theta is the angle between the force and the velocity. Well, let's do some exercises. The ability to do work or cause change is energy. Next, energy in the form of motion is its kinetic energy. Next, if the skier is at the top of the hill waiting for the whistle to blow for his turn to ski, he has what? After the whistle blows and he starts his ski run, he has what? So the first one, he has height, and then the second one, he has motion. So the answer is D. The last one. According to the law of conservation of energy, the amount of energy before and after a reaction must be the same. Which statement below is true? The answer is the total amount of energy is conserved. Well, that's it for Chapter 5 lecture. Thank you so much for listening. See you later, guys.